Hello everyone. So today we're going to continue with stats, but we're going to look at some z-scores. And I know that's something you might not have heard about before, but it is generally figuring out standard deviations when they're not 1, 2, 3. All right, so let's look at doing this today. You're definitely going to want to have Desmos open because this is very difficult without Desmos. They used to have to look at a chart, which I think is ridiculous. A statistical measurement of a score's relationship to the mean of a group of scores. A z-score of 0 means the score is the same as the mean. A z-score can also be positive or negative, indicating whether it is above or below the mean and by how many standard deviations. So to find the z-score, you do your raw score minus the mean divided by the standard deviation. So there are some symbols that we're going to be working with. So we've been doing everything with sample populations, and our mean has been that x bar, and our standard deviation was s sub x. Sorry, that doesn't really look like an s, but it should be an s sub x. Now, when we're talking about the entire population of something, that's when you're going to have something called a mu. I'll do that in a different color. Mu for your mean, and a sigma, lowercase s in Greek, for your standard deviation. So you'll sometimes see that. Now z-scores are just going to be numbers between these. So these are standard deviations. This is the mean. Z-scores are going to say I'm 1 standard deviation above, or maybe 1.77 standard deviations above. And you're going to find that. So to find your z-scores, there's two ways. You do your original minus your mean, but this is for a sample population, over your standard deviation. And then for the entire population, it would look like this: x minus mu over sigma. So it's just going to depend on if you're doing a sample population or entire population. Often they don't tell you, so you can use these kind of equations interchangeably. Suppose a normal distribution has a mean of 10 and a standard deviation of 2. Find the z-scores of the following measurements. So we take our raw score, we subtract our mean, and we divide by a standard deviation. So 9 minus 10 is negative 1 divided by 2. This means this has a z-score. We're just going to label it as z right now, of negative 0.5. Meaning it's about half below the mean. About half of a standard deviation below the mean. For the next one, we do 10 minus our mean of 10 divided by 2. 10 minus 10 is 0, divided by 2 is 0. So our z-score here is 0, meaning it is on the mean. Here it is 0.5 standard deviations below mean. Okay. For our next one, we do 11 minus our mean of 10 divided by our standard deviation of 2, and you get 1/2. So our z-score is at 0.5, and it is 0.5 standard deviations above mean. And we're using really simple numbers right now. Normally this is going to be used with a lot of decimals. And finally 14. So 14 minus 10 divided by 2 equals 4 divided by 2 equals 2. So our z-score here is 2, meaning 2 standard deviations above the mean. Okay. Now, suppose a data set is represented by a normal distribution with a mean of 125 and a standard deviation of 7. What data value is 2 standard deviations above the mean? So we want a z-score of 2, and we need to know the x for that. So 2 equals x minus our mean of 125 divided by 7. So we're going to multiply 7 on both sides. We get 14 equals x minus 125, add 125, and you get 139 equals x. Now I'm going to be real. The faster way to do that, at least to me, is I need 2 standard deviations above. So 2 times 7 is 14. Add that to my mean of 125, and I get 139. I can do that in my head, but this isn't always going to be as simple as that, so that's why we do this. Also, you could draw it out. It's up to you. But this is the technically math way to do this. What data value is 3 standard deviations below the mean? So this was above. So my z-score here was 2. My z-score here is going to be negative 3. So it would be negative 3 equals x minus 125 divided by 7. Multiply 7 on both sides. We get negative 21 equals x minus 125. Add 125. And you get x equal to 104. And that's how you do that part. All right, in example 30, in a normally distributed data set, find the value of the standard deviation if the following additional information is given. So the mean is 22.6 and the z-score for a data value of 230 is 0.2. So the z-score is 0.2, the data value is 230, the mean is 22.6, and I need to find the standard deviation. Now, we can use sigma or S sub x. It's up to you. I'm just going to use sigma because we haven't seen that a lot. So because these can be interchanged, because I can multiply by sigma and then divide by 0.2, or if we say multiply by the reciprocal, pretty much these can trade out. So sigma is equal to 230 minus 22.6 divided by 0.2. Now I'm going to go over to Desmos to put this in because this is a little bit difficult for me to do in my head. 230 minus 22.6 is 207.4 divided by 0.2. We get 1,037. That's a big standard deviation. Personally, I think so. Okay. And for the next one, the mean is 9.8 and a z-score of the data value of 10.3 is 2. So the data value is 10.3. And that's going to equal 2, our z-score. And so we can interchange these, and we get sigma is equal to 10.3 minus 9.8 over 2, which is equal to 0.5 divided by 2, which is 0.25. So this equals 0.5 divided by 2. Half of 0.5 is 0.25. And that's your standard deviation there. Okay. Let's keep going. So for the next one, for like all of these, I really suggest sketching a normal curve and labeling the x-axis so you can see what's going on. So example 1, a forest products company claims that the amount of usable lumber in its harvested trees averages 172 cubic feet, averages meaning that is the mean, and has a standard deviation of 12.4 cubic feet. Assume that these amounts have approximately a normal distribution. So let's draw our normal distribution. The average is 172 and a standard deviation of 12.4. 1, 2, 3. So add 12.4, I get 184.4. Add 12.4, I get 196.6. Add 12.4. Oh, 0.8, sorry. Add 12.4 to that, I get 209.2. I'm going to double check that one. 196.8 plus 12.4. 196.8, 209.2. All right, so likewise, we're going to go back the other way. So if this is the mean, this is 1, 2, 3. I need to do -1, -2, -3. And I am going to subtract 12.4 from each of these. So 172 minus 12.4 is 159.6. Minus 12.4 is 147.2. Minus 12.4 is 134.8. I'm going to double check that last one. 134.8. Okay, we're good. So now that we sketched it, it says, what proportion of trees contains more than 150 cubic feet? So 150 would be somewhere in here between 147 and 149, closer to 147, and it's more, so I need all of this. Now, to figure this out, I need to first find the z-score. So it's 100, z is going to be equal to 150 minus 172. So my original minus my average or mean over my standard deviation. Let's just straight up put this in here. 150 minus 172 divided by 12.4. And I'm going to round to the nearest hundredth with z-score. So this is negative 1.77. Now, this is where it gets interesting. I need everything from negative 1.77, which is right here. That's that z-score, and above, because I need to go everything up. Proportion trees contain more than. So I need to go from negative 1.77 to infinity. And this is going to be a normal distribution. So when we get to Desmos, we're going to type in normal dist. That's what it represents. Now, I'm not going to put any mean or standard deviation in there because it's just a normal distribution, but I want to find the cumulative probability. So I'm going to check that off. The huge thing here is you have to look at what it wants. So the minimum is negative 1.77, and the maximum is infinity, which it is automatically going to be in there, but if you want to type it in to be sure, infinity, you can type in infinity. And it gives you the percentage right here. We're going to round to the nearest tenth of a percentage. So first I move the decimal 2 and then do it, and it would be 96.2%. So that is how I get that. Now these steps right here are for if you're doing it in the yellow calculators, the TI-84s. This is for doing it in Desmos. So you type in normal distribution, and then you use your, essentially your domain that you want to use. All right, now what proportion of trees contain between 175 and 190 cubic feet? So 175 is going to be around right here between 0 and 1. And 190 is going to be between 1 and 2. So let's figure out what they are. So the first z-score is 175 minus 172 divided by 12.4. Let's put that into Desmos. I'm going to leave the normal distribution up because it's going to make our lives easier later. 175 minus 172 divided by 12.4. And I get 0.24. So this z-score is 0.24. And then I have to do my other z-score because it has to be between this number and this number. The other one was from 150 to infinity. This is between two numbers. And I get 190 minus 172 over 12.4. So coming back here, let's change this 175 to 190. And I get 1.45. We're generally rounding to the nearest hundredth with z-scores. If you want to write that down, please do. So now I'm going to do the normal distribution, but it's going to be between 0.24 and 1.45. So we're going to change this one to 0.24 and this one to 0.45. 1.45, sorry. 1.45. And I get 33.2%. Remember, these are rounding to the nearest thousandth first and then moving the decimal twice. Or you can say move the decimal twice and then round to the nearest tenth. Okay, we're going to try another one. Healthy 10-week-old domesticated kittens have average weights of 12.5 ounces. So that, remember, the average means my mean. I'm going to draw my bell curve and start drawing this as I go. So this is 24.5. Ooh, that was really wrong. 24.5 with a standard deviation of 5.25 ounces. So one standard deviation away, adding 5.25, I get 29.75. Two standard deviations away, adding 5.25, I get 20 or 30, 5 even. And adding 5.25, I get 40.25 for 3 standard deviations away. Going the other way, subtracting 5.25 is going to give me 19.25. Subtracting it again will give me 14. And subtracting it again will give me 8.75. Okay. The distribution is approximately normal. A kitten is designated as dangerously underweight when at 10 weeks it weighs less than 10 ounces. So 10 ounces would be somewhere in here. What proportion of kittens will designate as dangerously underweight because they're less than 10 ounces? Meaning I need to do 10 ounces right here and everything less. Well, I guess I shouldn't have. It's just this down here. Shouldn't really do everything up above the normal curve. Okay, so now we're going to plug this in. So 10, my z-score is going to be 10 minus 24.5 divided by 5.25. This gives me, let's just put it into Desmos. So 10 minus 24.5 over 5.25 gives me negative 2.76. That's my z-score. And I need to go, that's my maximum. That's my maximum because I need to do everything less. So it's from negative infinity to that. So let's change our minimum to negative infinity. And our maximum is negative 2.76. And I get 0.3%. 0.3% because it's 0.0028. That goes to 0.3%. So only 3%, or 0.3%, sorry, 0.3% of kittens will designate as dangerously underweight. Thank God, because I don't want underweight kittens. All right, so this next one is for you to try. Pause the video and try to do it yourself. Suppose that there are 100 franchises of Betty's Boutique in similar shopping malls across America. The gross Saturday sales of these boutiques are approximately normally distributed with a mean of $4,610 and a standard deviation of 370 or 980, 350, 720. Other way, minus 370, 4240, 3870, and one more. I did not draw this well at all. Minus 370, 3500. Okay. So find the z-scores of each of the following gross Saturday sales amounts. So z-score for the first one is 3870 minus, which is right here. So I know it should be 2 below, but let's make sure. Minus 4610 over 370. Because 3870 is on here, meaning it's 2 standard deviations below this mean. So let's make sure we get 2 standard deviations below. All right, so this one is 3870 minus 4610 divided by 370. And I get negative 2, or 2 standard deviations below. For my next z-score, it's 4425 minus 4610 over 370. Let's see what this one gives us. 4425. I get negative 0.5. And for the last one, 5535 minus 4610 over 370. 5535 is above 2. So that'll be interesting. It is 2.5 above. Okay. So now let's look at So we did our work there. Let's look at C. What percentage of Betty's Boutique franchises had gross Saturday sales between 44.25, which is negative 0.5, and 55.35, which is 2.5. So it's between these two z-scores. So we're going to throw them into our z-scores. So negative 0.5 and 2.5 would give us 68.5%. Okay, for the next one. What percentage had a gross Saturday sales between 38.70 is the first z-score we found, or negative 2, and 55.35, which is 2.5. So between negative 2 and 2.5. Negative 2 and 2.5 is 97.1%. Okay, last one. What percentage of stores had gross Saturday sales less than 55.35? So less than 2.5. So 2.5 is the high. Negative infinity is the low. And it's 99.4%. It helps to show the domains that you're doing. All right. Your activity today is to do the homework. It is only 4 problems, so you guys should be perfectly fine doing that. I hope you guys have a wonderful day, and I will talk to you later. Bye.